Mm-hmm.
You just keep doing chain rule. Yeah, if you take the chain rule.
You could, but my suggestion is always, if you ever see a log problem, see if you can apply properties so you can avoid more difficult holes. So what's a way that we can deal with this clearly? Rewrite it as well.
Okay.
And then once you rewrite it to the 1/2, what can we do? We haven't changed anything yet, but we've made our equation a lot easier to find the derivative. Oh, much prefer find the derivative here without chain rule than with this using chain rule. You can see a log expression. It doesn't always mean that you can always expand, but always consider the possibility of expanding to hopefully ease the calculus procedure. So number one, we want to make sure that we take the time to rewrite that cosine squared as bracket cosine squared. Or like clear, makes it more clear to recognize, oh, there's that outside portion, that bracket squared. I got to take the derivative of that portion first, and then I can move on to the cosine derivative, which then becomes negative sine of u times u prime. Number two, once you rewrite that mathematical raised to the 1/2, you can bring that 1/2 down. Now we can have a much easier time finding the derivative. The natural log of u is just u prime over u, and that 1/2 is going to hang out in front. Number three, hopefully we see that there's a need for implicit because you see y, that y variable kind of mixed into the equation here. And then also there's that need for product rule as well. It's kind of hiding that 10xy. We can't just say, oh, 10x derivative is 10 and y becomes dy dx. Those are two variables being multiplied together. We have to go through the full product rule on that right side, that 10xy there.
Why didn't you put negative 1/2 for the x for the second?
So to go from here to here, this is not a calculus procedure. This is just a power property. So we just bring that 1/2 down because these are equivalent. Now, if it was x plus 3 to the 1/2, then we would go through a quotient chain rule, bring that 1/2 down, put that one. This is just a log property. So for number 3, once we go through power rule, implicit, and product rule on the right side, once you're pretty much done with your calculus portion. The rest of it is just trying to clean up. So now I'm just trying to add and subtract the terms in a way where I can collect my dydx terms together on the left side. So I can factor those dydx out. And then once you get dydx by itself, I'm not going to be picky about whether you clean up your expression. But I do want you guys to see how I got to this answer because, free response, you leave your answer unsimplified or multiple choice. Typically, your answer choice will be simplified. And just be careful that we cannot cancel across addition or subtraction. So we can't take a bunch of these x's and y's out because these are both attached to another term by addition or subtraction. Maybe tomorrow we can spend some time doing a practice run through all of our derivative rules. So remember, with arc trig, there's basically just only 3 rules, right? You got arc sine, arc tangent, arc secant, and arc cosecant is basically the same thing as arc secant. It's just with the negative. Any questions 1 through 4? Yeah. Yeah, some students get mistaken when that 1/2 comes down. They feel like it's power rule for derivative, but it's only power property for log. When you bring that 1/2 down, you don't subtract one from the exponent, you just bring it down. It just makes it easier for your derivative step. Item 6, understanding of the relationship between a function and its inverse, that their order pairs are flip-flop, but then their derivative at their corresponding points have reciprocals of each other. So I go through the chart to help me progress through the relationship there. You know, if you have any questions that you're going through the review. On second. On the back page 7 and 8, you're going to be doing this, finding the second derivative. So you have to go through that derivative process twice. It wouldn't fit. Good point. Number 8, I chose to push that 1 minus 2y up to the top and go through chain rule. But you could just easily go through quotient rule if you feel like you want to do that. But I decided to go through chain rule. So sometimes there are multiple ways that you can work through a problem. So So the idea is that a function and its inverse will always have flip order pairs. So for instance, let's say I had function and its inverse, right? Um, their order pairs will be flip-flopped. So let's say this was 1, 4, then there must be an order pair for 1 and then at their corresponding points, their steepness will be reciprocal to each other. So this is the slope of 5. This slope must be 1/5. So I like to build out the relationship this way, where anything that I'm looking for, I'm going to start down here. So in this case, I'm starting with g prime of -1. I don't know what that is yet. I know that -1 is the x value of my g function, which must mean that -1 is the y value of my f function, because f and g are established to be inverse of each other. So I know that f of some value must be. So then from this, I can figure out what has to go into pieces here. F of 4 is -2. That's not going to fit, but f of 6 is -1. So then there must be, if there's an order pair 6, -1, that's here, there must be an order pair -1, 6 out of this one. Because they're so the idea is that if I can find the slope of the f graph at 6, this number will be used to help me get to the number that one. Okay, so the slope at 6 is 3. So if this is slope 3, this has to have a slope of 1/3. The only thing you're doing is reciprocal. Don't change the sign. So these will always have the same sign. That's right. I always start here and I'm move my way around so I get the Number 12 on my answer key got cut off, so the answer is 3 pound of 8 is negative 1/3. In case you're already at the 12 checking your answer.
Why is it number 10?
Yeah, that's my mistake. I misnumbered. Let me know if you have any questions. Keep working for another 10 minutes or so. And make sure if you're entering and leaving the classroom that you just close the door fully. Tomorrow, we're going to continue working on our test review. But tonight, you guys will finish up on AP practice for homework. All right, complete your phones.
Yeah.